Hello friend, I am Archit from InsideAIML, and in today's session we will understand about K nearest neighbors, or also known as KNN. But before deep diving into the KNN, we'll first go through today's agenda. So the very first thing that we will see is what is KNN. Then we'll go to the industrial use of KNN and we'll see where in real world scenario KNN is applied. Third comes the most important topic, what is K in KNN? There has to be something and how it is decided. Fourth, we'll go through the working of KNN and how KNN exactly works. 5, we'll come to the point of how to choose the optimal value of K, as it is one of the most important topic in KNN, how to choose the value of. The last, we'll see what are the advantages and disadvantages of KNN. So let's get started. What is KNN? KNN suggests that if you are similar to your neighbors, you are one of them. Now how it is. For example, an apple will look more similar to a mango or an orange than a monkey or a dog. So it is most likely to be belong to a group of fruits than a group of animals. So it is a simple algorithm that uses the entire dataset in its training phase, and when a prediction is required for an unseen data or a completely new data, what it does is it searches through the entire dataset for k most similar instances, and then the data with the most similar instance will be returned as the prediction. KNN is used in search functions when your objective is to find any item which is similar to the other. Let's define K nearest neighbors. K nearest neighbors algorithm uses a feature similarity to predict the value of the new data points, which further means that the new data point will be assigned a value based on how closely it matches to the points in the training dataset. And in this case, which are the points which they're going to closely match it to? The neighbors. Now we'll see some of the industrial use of KNN. One of the most common use of KNN is the recommendation system. KNN is used in recommendation system for business stuff like in Amazon or in media stuff like in Netflix. I hope all of you must have used Amazon at least once to buy the stuffs. And we must have seen the similar item section or the bottom of the page or the frequently bought together section at the side of your screen. All this suggests that the page or the code uses KNN. All the suggestions that you're looking at is a result of KNN. KNN finds the frequently bought together items and then placing them in front of you to lure us in buying the more products and increasing your basket value. And the more products that you buy from Amazon, the more money that they earn. Around 35% of Amazon revenue come from this only. So it proves that this technique is working wonders for them. Now, you may think, what is that K in KNN? Well, K is the number of nearest neighbors which are the voting class for the new data point, or you can say the test data point. For example, if the value of K is 1, then the testing data is being given the same class as the nearest neighbor. Similarly, if the K is 3, the label of the 3 closest classes is checked and the most common is assigned. As you can see in this example, if the value of K is 3, we check the 3 closest points. And out of the 3 closest points, red has the common color. So we assign red color. But if we take K as 5, the most common color is green. So we assign it to green. So this is what K is in K nearest neighbors. Moving to the next section, we'll understand how KNN works. For this, let's take an example. Let us assume that we took the measurements of length of ears and sharpness of claws of many cats and dogs. And then we plotted the information on XY axis, X being the length of the ears and Y being the sharpness of the claws. We have the same information, that is the length of the ears and the sharpness of the claws, for a completely unknown animal. And we have to decide whether the animal is a cat or a dog. Now this is a perfect scenario for KNN. What we do is we're going to plot the information of the unknown animal on the XY axis. As we can see that between the cats and dog groups, there is a black color animal which we have no idea about that it belongs to cats or dogs. For this example, we're going to take the value of K as 5. So we will find the 5 nearest neighbors of the unknown animal. And then, depending upon the most common animal in the group, we will come out with the conclusion. And in this example, we can see that there are 4 cats and 1 dog. So as the number of cat is very much higher than the number of dogs, we will come to the conclusion that the unknown animal is a cat. So this is exactly how KNN works. Now, going through the algorithm of KNN, you may think how we choose the value of k as 5. There has to be a reason behind it. So there isn't exactly a rule that you have to follow to choose the value of k. It is completely different, or you can say completely specific to different scenarios. But there are some guidelines that you have to follow to choose the value of k. The very first is the square root of n, in which n is the total number of data points. So if the graph you have has 25 data points, you may take the value as 5 or some number around that. The second, that you should have only the odd values of k, so that to avoid the confusion between two classes. It is, so we can take this example by, if we have the value of k as 5, then there is no possibility that two classes can have a similar amount of effect. But what if we take the value of k as 6? There can be a chance that one class has 3 instances and the other class also has 3 instances. In this case, there's a confusion between the two classes of data. So it's good to have an odd value of k. But in real world, the value of k is being found out by cross-validation. In simple terms, cross-validation is just trying out different values of k for the same problem and finding the best answer, or the value of k for which the least error is present, and the value of k has been taken. As we can see in this graph, it has been tested for different values of k. To be specific, it has been tested for the values of k between 0 to 40. And in that, at k is equal to 20, the error is at the lowest point. So we can consider that the value of k should be 20 in this particular case. Now, let's check some of the advantages of KNN. The very first advantages of KNN is no assumptions about the data. As we have seen in the working of KNN, there is no assumptions taken about the data, like we took in linear regression, which is really helpful when we are dealing with problems which have a non-linear relationship. Second comes no training phase. This is one of the biggest advantages of KNN, that it has no training phase. As soon as you provide it with the data, the model will be ready to carry out the predictions. This is really helpful when we are short on computational resources. Even though it has no training phase, it is really highly accurate and very robust. The third comes is its simplicity, or the simple algorithm. During the explanation, we have saw how easy it is to understand KNN. It does not have any complex computational concept like in linear regression or logistic regression. And because it's of simplicity, it is very easy to explain and understand. As we can see, there are many things that are going for KNN, but every coin has two sides, and KNN is no exception. After looking at the advantages, let's check some of the disadvantages of KNN. The very first disadvantages of KNN is that it's a lazy learner. A lazy learner is an algorithm which does not have a training phase. Although it makes it computationally easy to process, it is highly prone to outliers and missing data. Instead of training itself on the training data, like in logistic or linear regression, it just memorizes the training data. So if your data has too many outliers, it can affect your classification model in a bad way. The second comes is the deciding of value of k. We need to specify the value of k beforehand, which is sometimes become very tedious task, as choosing the wrong value of k will make your model to predict bizarre results. In order to find the optimal value of k, we need to have a good understanding of the problem statement, and we should be completely aware of all the features of the dataset, as any small error can degrade our model. Third comes the expenses. KNN might not have the training phase, but it does not mean that it is not computationally inexpensive. For every prediction that KNN has to make, it uses the whole training dataset, which is computationally very expensive. Also, during the process of finding the value of k, the optimal value of k, using the cross-validation, we have to carry out the test predictions numerous amount of time, which only adds to the expenses of the computation. So these are the some disadvantages of KNN. So as we can see, even KNN does not have all the advantages, it has some disadvantages. With this, we came to the end of this video. Feel free to drop your suggestions into the comment box, and if you have any doubts, you can also put them into the comment box. We'll be really happy to help. And for more information, you can always visit our website www.insideaiml.com. Thank you.